Imagine, for a moment, that every grain of salt in the ocean simply vanished. Not the water. Just the salt. The seas stay exactly where they are, the same blue, the same depth, the same endless horizon. It sounds almost harmless. A cleaner ocean. Fresh water from pole to pole. But within hours, the planet you know would begin to die. And within a few short years, Earth could become a world almost without life. This is what would really happen if you removed all the salt from the ocean. Let's start with the scale of what we're talking about. The world's oceans hold about 50 quadrillion tons of dissolved salt. If you could extract it all and spread it evenly across the land, it would form a layer roughly 160 meters thick, taller than a 40-story building, covering every continent. The ocean isn't lightly salted. It is a vast, planet-sized brine, and almost every system on Earth has been built around that simple fact. The first thing to break would be life in the water itself. The creatures of the sea are not just floating in salt water, they are in chemical balance with it. Their cells hold a careful concentration of salts that matches, or deliberately offsets, the water around them. Take the salt away, and a process called osmosis turns deadly. Fresh water rushes into their cells, trying to balance the difference. Fish would swell. Their cells would rupture. From the smallest plankton to the largest whale, marine life would suffer a kind of internal flooding. Most ocean species would die within hours to days. And these aren't isolated deaths. The ocean is a single connected web. Remove the bottom of it, the plankton, and everything above collapses. That word, plankton, is where this story turns truly frightening. Phytoplankton are microscopic plants that drift in the sunlit upper ocean. They are so small you'd never notice them. And yet, together, they produce somewhere between half and two-thirds of all the oxygen on Earth. Every second breath you take comes not from forests, but from the sea. These organisms are exquisitely tuned to the salinity of ocean water. Strip the salt away, and they die almost immediately. When the plankton go, the planet's oxygen supply begins to fall, slowly at first, then steadily, year after year. Forests would help, but forests alone cannot replace the lungs of the ocean. We would be living on a planet that is quietly running out of air. But the salt does something else, something most people never think about. It drives the weather. Salt water is denser than fresh water, and that difference in density powers what scientists call the global conveyor belt, a vast, slow current that moves heat around the entire planet. In the North Atlantic, cold, salty water sinks, pulling warm water up from the tropics behind it. This is why Northern Europe, which sits at the same latitude as frozen parts of Canada, enjoys mild winters and green fields. That warmth is delivered by salt-driven currents. Remove the salt, and the conveyor belt stops. The density difference that drives it is gone. The heat stops moving. The tropics would grow brutally, unbearably hot, because the warmth that used to flow toward the poles now has nowhere to go. And the higher latitudes, Europe, Northern Asia, parts of North America, would plunge toward a deep freeze. You would have a planet of violent extremes, scorching at the middle, frozen at the edges, with monstrous storms tearing along the borders between them. The gentle, stable climate that allowed human civilization to grow crops and build cities for the last 10,000 years would be gone. And we haven't even talked about the rain. The oceans are the source of nearly all the moisture in our atmosphere. As salt-free water evaporated differently, as currents died and surface temperatures swung wildly, rainfall patterns across the world would shatter. Some regions would drown. Others would never see a cloud again. The breadbaskets of the planet, the great farming regions that feed billions, depend on predictable seasons and predictable rain. Take that away, and the food simply stops. Here is the chain, laid bare. The salt vanishes. The sea creatures die. The plankton die. The oxygen begins to fall. The currents stop. The climate fractures into fire and ice. The rains fail. the crops fail. And humanity, sitting at the top of a food web that has just had its foundation pulled out, would face a collapse unlike anything in recorded history. Not in centuries. In years. There's a strange irony hidden in all of this. We often think of salt as something to be avoided, too much of it in our food, in our soil, in our drinking water. Fresh water is precious, salt water is the thing we can't drink. And yet that same salt, the thing we'd happily remove if we could, is one of the quiet machines that keeps the entire planet alive. It regulates temperature. It powers the great currents. It holds marine life in chemical balance. It is, in a very real sense, part of the operating system of Earth. Scientists actually study a gentler version of this question, because it isn't entirely hypothetical. Climate change is adding enormous amounts of fresh water to the North Atlantic as the Greenland ice sheet melts. That fresh water lowers the salinity in exactly the place where the conveyor belt begins. And there is growing evidence that this current, the Atlantic meridional overturning circulation, is slowing down. We are not removing all the salt. But we are diluting it, in the most sensitive spot, faster than at any time in the last 1,000 years. The thought experiment of an ocean without salt is extreme. The real-world version is already, quietly, beginning. So the next time you taste the sea on your lips, or wince at salt water stinging your eyes, remember what that taste actually represents. It isn't a flaw in the ocean. It's the reason the ocean works. It's the reason the air is breathable, the climate is livable, and life, your life, is possible at all. Remove it, and you don't get a cleaner, fresher world. You get a beautiful blue planet, slowly going silent. The ocean salt has been here for billions of years, dissolved out of ancient rock, carried by every river, concentrated drop by patient drop. It built the conditions for life, and then it kept them stable long enough for something remarkable to happen, for creatures to crawl out of that salty water, stand up, look around, and begin to ask questions like this one. The salt didn't just make the ocean. In a way, it made us. And that is a debt we almost never stop to consider. If this made you see the ocean a little differently, you're exactly the kind of curious mind this channel is made for. Subscribe, and stay curious. There is so much more hiding just beneath the surface.